All right, so welcome to part two. We're going to talk about transformations. Basically, transformations, all it is just kind of how functions move on a graph, moving up, moving down, moving left, moving right, stretching, flipping, a lot of things like that. Now, personally, I think a lot of this is really, really easy without a graphing calculator if you just know how to look at the equations properly. But sometimes maybe graphing calculators can be better off. So I'm going to do this first video without a graphing calculator. Uh, like I said, I think it's simple enough once you understand it. But if you want to jump into the calculator one as well, you can see what everything is all about. So number one, don't need a calculator because it's already graphed for you. So given this graph, which transformation best describes the graph below? So what it's asking us to look at is, notice where the graph is right now. Right there. See how it kind of crosses there at one. And look at it when it's moved. Well, it's basically, it looks like the graph was shifted downwards, right? It doesn't look like it was moved left to right. It just looks like it was here roughly, and now it's moved down a little bit. So it seems as if it's moved down 2 units. So that's all transformations really are. So when you graph it in a calculator, that's kind of the thing you'll look for. All right, so this is a very, really good one to look at in the calculator. But you don't have to use a calculator to, if you know what it means, it's pretty easy to answer. So we have y equals 2x plus 5. And if we change the slope to -2, how does the graph change? Well, one thing that we talked about a while ago, and I guess I'll pull this up here, is our transformations. We had f of x plus k. This tells us a vertical shift. So vertical meaning moving up or down. We had f of x plus k with the k in the parentheses, which told us it was a horizontal shift. So yes, this is the stuff we're doing here. Horizontal shift, which means left or right. Then we had k times f of x, which when you multiplied a number to your function, this would stretch it or squish it, but we'll just say stretch. So it could make it, example, really, really skinny or really, really wide. It wouldn't move it. It would still have sort of the same center point, but it would make it either really skinny or really wide, just depending on the number you're multiplying it by. And then the last one was negative. It would flip, or in a sense, opposite, right? So if you had a function that was going upwards, well, if you make it negative, it's now going to be going downwards. But for a line's sake, for a line is just a line, right? But if you make the function negative, well, that line's going to go the other way instead. So rather than going upwards like it was originally, the line would be going downwards if it was negative. So that's what the question here is saying. Is if you change, it's right now, it's currently, it's y equals 2x plus 5. But if you change it to y equals negative 2x plus 5, because the slope is the 2 part. So if you change the 2 part to a negative 2, what's going to happen to the line? Well, your slope from originally going up 2 over 1, which would look like this, is now going down 2 over 1, which means it would look like this. So on a graph, that would appear as if the graph slants the opposite direction. It's not more vertical. It's not, does not change. It's not, the graph is more horizontal. It is the fact that it goes the opposite way. And if you graph these two lines, you'll see exactly, that image. One's going like this. The second one's going like this. It's clearly going the opposite direction because it's doing the negative. It's putting a negative in front of the 2. And by doing that, it changes the function orientation from upwards, downwards, but in this case from positive to a negative slope. So which function describes the graph of y equals x plus 5 squared minus 2 differs from the graph y equals x squared? So this goes back to what I was saying about these transformations here, is that with the function y equals, and what was it again? I gotta go back. X plus 5 squared and minus 2. From the original function, which the original function is saying was y equals x squared. Well, there's two new features. I still have the x squared here, but I have a plus 5 right there, and I've got a minus 2 right here. So how is that going to shift things? Well, if we go look at these four transformations here, this plus 5, being the fact that it's inside the parentheses, represents what is going to be a horizontal shift because of where that 5 is inside that function. The 5 being inside the parentheses tells me that it's going to be a horizontal shift. Now, if it's plus 5, it means it's left. So plus is left, minus is right. So this tells me the plus 5 on the inside is horizontal, but because it's plus, it means left. So I see this, and I immediately know that it means left 5. And now the minus 2 that's on the outside, the minus 2 is being tacked onto the end, so it's after the function, which is representative of my plus k here, telling me it's a vertical shift, meaning it's moving up or down. So plus would mean upwards, minus would mean down. So since it's minus 2, that tells me it's moving down. So I see this as left 5, because plus 5 being in the parentheses, and then down 2, because I see the 2 on the outside of the parentheses. So that's what I'm seeing. And that option is indicated to us in option 3. All right, so number 4 is basically the same kind of question. Notice a distinct difference between the original function, which is just x to the third, and this one, which is x minus 3 to the third. So clearly point out what's different. What's different is this minus 3 here. And notice where it is. It's inside parentheses. So that tells me it's based on my horizontal shift when it's inside parentheses. So that tells me it's either left or right. Now remember, minus means right and plus means left. So because it's minus 3, it would be right 3, which tells me it is option 1. Number 5, again, basically another very similar question. We have the original function, which is the square root of x. And look what you're doing. You're putting a 2 inside the square root. So because it's inside the square root instead of outside, that tells me, again, yet another horizontal shift because it's inside. So if it was written as a square root of x plus 2 with the plus 2 on the outside, that would tell me vertical. But because that 2 is extended, that 2 is on the inside, it's horizontal. So notice the difference between this and that. It's a big difference where that 2 is located. If it's inside the radical sign or if it's not. Because it's inside, it means horizontal. And because it's plus, it means left. So I would say left 2 units, which means option 2. Number 6. Sort of the same as the previous questions, but kind of the reverse psychology part of it. So instead of giving you the 2 equations and noting it's translated, it's telling you translated, and I want you to pick the equation. So it says translated up 6. So up means vertical. So I'm expecting my function, I'm expecting to add 6 because it says up, and up means plus. Adding 6 to the outside of my function. My original function was x. So I take the y equals x, and I add a 6 to the end of it. Well, then I'll have my translated up 6 graph. So it's clearly option 3. Okay, you're basically looking for, when it says up 6, which one has a plus 6 outside of it. Not inside of it, but outside of it. And when I mean outside, I mean not in parentheses. If it's in parentheses or inside absolute value bars or inside a square root, then it's inside. But if it's not in anything, then it's outside. Number 7. So this is a little bit interesting. This is one where a graphing calculator really would help, I guess. But if you know enough about transformations, you'll be able to figure this out. So notice, you'll probably remember when we originally went over stuff like this, that originally this function is centered at 0, 0. So it looks something like this. But it's not there anymore, right? It's not at 0, 0. It's been moved. That vertex point has been moved from 0, 0 over there. So how did it move is the question. Well, if it moved from here to there, it's gone to the right 3. So I'm going to make a note of that. It's gone right 3. And then it would have had to go up 2. It doesn't have to go in those particular orders, but it had to go right 3 and it had to go up 2. So I'm going to look at my solutions here and figure out which one says right 3 and up 2. Now, up means vertical shift, so I'm expecting a +2 on the outside. And right 3 is a horizontal shift, so I'm expecting right is -3 on the inside. That goes back to my f of x plus k and my f of x plus k. Inside parentheses versus outside. So outside means it's horizontal, and up 2 are vertical, and up 2 is vertical, so I'm expecting 2 on outside. Horizontal is right, so I'm expecting my horizontal shift for my -3 to be on the inside. So I'm choosing the option that has a +2 on the outside, a -3 on the inside, and that is option 1. If that makes any sense. If it doesn't, please go watch the graphing video for sure. So which following is a parent function of the graph? Well, you just need to note that what function takes this shape. So let me kind of remind you what some of these look like. So yeah, we're looking at which function takes basically this weird arching shape. Well, I'll tell you what every one of these has. It's option 1 is a square root function. And a square root function, if you graph it in the calculator, will give you an arching shape. So it's probably option 1. But just to explain what the other ones look like, a cube root, what does a cube root look like? That's one that I'll graph in the next one. 1 over x and x squared. I know x squared is a parabola. I know this clearly isn't a parabola, so I wouldn't choose that. As far as the shape goes, though, use your calculator and graph these things and see which one has a shape resembling the one in this graph. But it should be option 1. So number 9, which graph best represents the following equation? So this is very similar to number 7, except you're given the equation, and now I want you to find the graph. So in this equation, I'm looking at my +2 on the inside. So the +2 on the inside tells me a horizontal shift. +2 means left 2 because it's on the inside. The +1 on the outside, because it's not inside the absolute value bars, +1 on the outside means it's vertical shift, meaning it's going up 1. So I'm basically looking for a graph. If I start at 0, 0, where that center of that graph is left 2 and up 1. So I'll start with option 1. If I look at option 1, I would have to go left 2 and then up 1, and I would get there. So it's probably option 1. It is option 1, actually. But just to express the other ones, it's definitely not option 2, because if I go left 2 and up 1, I don't hit anything. Option 4, I go left 2, up 1. I'm not at the vertex. I'm on the line, but I'm not at the vertex. I'm looking to land at the vertex, which is not left 2 and up 1. And then option 3, left 2 and up 1. We're looking for the vertex that's been moved left 2 and up 1 from 0. So if you start at 0 and you go left 2, up 1, you get that vertex. It's definitely option 1. Number 10. Number 10 is a little tricky. Well, it's not tricky, but read the question carefully. It says identify each function. That's the part that people misread the most. Each function that has transformed the parent function horizontally 3 units. So there's more than one option here. There could be 2, there could be 3, there could be 4, it could be all 5, who knows. But we're looking for functions, any of these, that tell me horizontal shifts of 3. So remember, horizontal is anything that has a 3 on the inside. Okay? It could be +3 or -3, but it has to be adding or subtracting 3 on the inside. So it's not g of x because you're not putting anything inside the parentheses there. And it's not t of x because the plus 3 is on the outside, not the inside. So it's immediately just ruling out those. It's definitely h of x because you can see the minus 3 on the inside. And it's definitely q of x because you can see the plus 3 on the inside. But does p of x count? The answer to p of x is no, it doesn't count. It has to be plus or minus the 3 on the inside, not multiplying by 3 on the inside. So the two options that work for our answers are h of x and q of x, because both of them have a plus 3 or minus 3 on the inside of the absolute value bars. Is that it? That is it. I will talk about the same exact stuff again in another video with the calculator. So if you want to check out the calculator video, do that. If everything that I did here made sense, then don't worry about it. But I'll let you guys do your own thing. Okay. Good luck on the quiz.